Larger sample sizes reduce the uncertainty of the mean because they make the sample average more likely to be close to the true population mean. Imagine you have a jar of mixed marbles and you want to know the average weight, but you cannot weigh every marble. If you weigh only a couple of marbles, those particular ones might be unusually heavy or light, so your average could be far from the real average. As you weigh more marbles, the ups and downs from unusually heavy or light marbles tend to cancel out, so your measured average settles closer to the true average. Mathematically, the spread of where the sample means land gets smaller as the number of measurements goes up, specifically shrinking by 1 over the square root of how many samples you take, which means big increases in sample count give steadily smaller improvements. Students often think that doubling the sample size halves the uncertainty, but because the uncertainty decreases with the square root, doubling only reduces uncertainty by about 30%, so expect diminishing returns as you add more data. Another common mistake is believing that a large sample fixes biased measurements, but if your method consistently misses the true value, more samples will just give a precise but wrong answer. Fixing the measurement process is necessary first. Some assume standard deviation and standard error are the same, but standard deviation describes how spread out individual measurements are, while standard error describes how spread out the sample means are, and you divide the standard deviation by the square root of the sample size to get the standard error. For more videos and resources on how sample size affects uncertainty and other chemistry topics, check out www.gumballdegree.com.